Respected colleagues, my name is ICOA2025 from ICOA2025. Today, I will present our work on accident severity prediction using a voting classifier with Optuna optimization. Here is the plan of my presentation. First, I will start with the introduction and I will explain the problematic and the objective of our work. After that, I will present the methodology we used, then I will show the main results. Finally, I will finish with the conclusion. Road accidents are one of the major problems worldwide. Every year, they cause a very high number of deaths and serious injuries. Beyond the human loss, they also generate important social and economic costs. Being able to predict the severity of accident is essential. Accurate prediction can support emergency services, help authorities to plan safety measures, and contribute to reducing the impact of accidents. Severity prediction is difficult because the data is highly imbalanced. Minor accidents are frequent, while severe ones are rare. This makes critical cases harder to detect. Moreover, single models often overfit and lack robustness, which highlights the need for a more reliable and accurate approach. The objective of this work is to build a reliable system for accident severity prediction. We adopt a voting classifier that combines several strong models to improve stability and accuracy. In addition, Optuna is used for hyperparameter optimization, which further increases performance and robustness. The goal is to provide a high accuracy system that is consistent and useful for traffic safety applications. After presenting the problem and the main objective of this work, the next step is to describe the methodology that was followed. We used the US accident dataset. It contains millions of road accident records from 2016 to 2023 in the United States. This dataset is very useful because it includes many features such as weather, traffic conditions, and road infrastructure, which are important for predicting accident severity. In the original dataset, severe accidents are much less frequent than minor ones. This imbalance makes prediction difficult. To solve this, we use smooth and adazine, which generate synthetic examples of severe accidents. After rebalancing, the datasets become more balanced and the models can learn better to detect serious cases. After this, we tested several machine learning models apart. For example, logistical regression is simple but limited, SVM is powerful but slow, and KNN is sensitive to noise. Random forest is robust, XGBoost is strong with non-linear data, LightGBM is fast, CatBoost handle categorical data, and neural networks have high potential but need careful tuning. Each model has advantages, but none was perfect alone. To benefit from the strengths of different models, we combined them using a voting classifier. We applied soft voting, which means each model gives a probability, and the final decision is based on a weighted average. This assembled approach improves accuracy and makes predictions more stable, especially for severe cases. Here we can see how our voting classifier works. Each model makes its own prediction. These are then combined in the soft voting layer, which calculates a weighted average of their probabilities. The result is a single, more accurate and stable prediction. Finally, we use Optuna to optimize the hyperparameters for our models. Optuna automatically searches for the best values, like learning rate, number of estimators, and tree depth. This process improves accuracy and reduces overfitting. After tuning, the voting classifier becomes more reliable and consistent for accident severity prediction. Let's now examine how the ensemble model performed in practice. First, we compare the individual models with the voting classifier. While most single models reach around 77 to 80% accuracy, the voting classifier achieved 90%. This shows that combining models really improves performance compared to using only one. Then we evaluated performance by accident severity level. the voting classifier achieved between 86 and 94% accuracy across all classes, with high record for severe accidents. This is very important because severe accidents are the most critical to detect correctly. To better understand how the models make predictions, we also analyzed the confusion matrix and the ROC curves. The confusion matrix shows that most accidents are correctly classified, with very few errors between similar severity levels. The ROC curves confirm this, with an IUC above 0.96 for all classes. This means the model can separate accident severity levels very reliably. Finally, we applied Optuna to optimize hyperparameters, especially for XGBoost. As you can see here, Optuna selected the best values such as numbers of estimators, maximum depth, and learning rate. This automatic tuning process increased the model accuracy from 90 to 94% and gave an F1 score close to 0.94. With Optuna, the model became more stable and problems of overfitting and underfitting were reduced. Having evaluated the model's accuracy and reliability, we can now conclude and outline the next steps. To conclude, this study demonstrated that combining multiple models in a voting classifier significantly improves accident severity prediction compared to using individual models. With the fusion of Optuna for hyperparameter tuning, the model reached 94% accuracy with consistent and reliable performance across all severity levels. These results show that using several models together and automatic tuning helps improve road safety. Thank you for your attention.